Uh, so, thanks everyone. So, I will give a small introduction of Ramesh Thangavel. Dr. Ramesh Thangavel is a data science and analytics professional with over 22 years of experience in pharmaceutical industry, currently working with a top 5 global pharmaceutical company in USA. He has a PhD in agricultural economics from National Dairy Research Institute, Karnal, Haryana, in the north of India. He currently lives in Princeton, New Jersey, USA, with his wife and 2 daughters. Indian astrology is a passion for Dr. Ramesh, and he approaches the subject matter as an ancient statistical modeling framework. He aspires to bring in data-driven artificial intelligence and machine learning into astrological framework to make more accurate predictions beyond the recent LLM route. He has been blogging, speaking, consulting, and teaching about the astronomical dimensions and statistical framework behind Indian astrology since 2019 through his website aimlastrology.in and YouTube channel AIML Astrology, primarily in Tamil language. He provides a modern data-driven statistical perspective to an ancient subject connecting 2 different worlds. So you are very welcome to explore his free online resources to know more about his work. So we are really kind of honored to welcome a PhD here, because in astrology, as much as it is ridiculed, we have a lot of amazing scientists like Dr. Ramesh taking up the subject, which indeed is a real win for us. So it's yours from now. Yeah. We will be here, and if you want any help or if you want any interactions, you can give an introduction. Before that, I will set up the poll. Right?
Sure.
I will make you co-host. Just a minute.
Okay.
Are you able to share the screen?
Let me try.
I think you should be able
Yes.
to.
Okay. So let me.
Yeah. Okay.
Can you see my screen?
Yeah.
Can you see my screen?
We can. Yeah.
Okay. Sure. Ashwin, you want to run the poll now, or how do you want to proceed?
You can give an introduction. In the meanwhile, I will set up the poll.
Okay. Sure. Good morning, good evening, and good afternoon, everyone, wherever in the part of the world you are. So I'm happy to be here in this session. So this is the 3rd year AstroSynergy is running this program. Every year we see quite a bit of renowned speakers coming and presenting their perspective on astrology, world astrology, and there is a lot to learn from these sessions. Today, I'm honored to be with you to present some of my work related to Ayanamsa. And, this is the Muthu has been, always a welcoming host for me to put me on the stage for the global audience. Thank you, Muthu. Today, we will go through pretty much a lot of nuanced details about the concept called Ayanamsa. Ayanamsa is very special to sidereal systems. Today we are going to see pretty much, I would say, a concise overview of the whole framework as well as different Ayanamsa systems. And among the Ayanamsa systems, which is, I feel, based on my database evidence, which I feel more astronomically and astrologically sound. So that is what I'm going to present you today. And when Muthu is ready, probably we will get started. I mean, when Ashwin is ready, we'll do with the poll. Before we start the session, I just want to offer a small prayer. Do yourself, whomever your favorite god, so please offer them prayer. So my favorite god is Ganesha. So let me pray myself. You can do yourself. I invite Ganesha to be part of this meeting. So we will have his blessings today. And we will get into the interesting topic of Ayanamsa. So we are we have about 80 minutes to, I mean 2 hours, 110 minutes to go. I want to be mindful of everyone's time. So we are already past 10 minutes. So I want to divide this session into three subgroups, subtopics. The first one is going to be on the astronomy side of Ayanamsa. So where we will understand Ayanamsa from an astronomical perspective. The second part of that would be more on understanding the current Ayanamsa systems. So there are about 40 plus Ayanamsa systems, different schools, different ideas, and all of that. We will take an overview based on the stars that are behind those Ayanamsa that we will see. And then we will see how those Ayanamsa are actually implemented in the software, some of the software, favorite softwares. And that will provide us the actual astronomy as well as astrology that we will see. And then the third part would be, so is the current systems sufficient enough, or do we need to look at it from a different lens, an additional lens from a statistical perspective on putting it along, whether is it a single star based system makes sense, or should we look at the whole principle of 27 stars? Nobody has attempted that. And um, interestingly, I have, this is my kind of my English version of this presentation. I have done a detailed 10 plus hours session in Tamil language on Ayanamsa. If you are familiar with the language, you could go over, and then I go into very detail. Given the time limitation today I will just provide an overview without going into too much of details for those systems. I hope you all will be thrilled. So let us take the small poll, and then I want to get a perspective before we go ahead so that I can customize my presentation on the fly. I have over 100 plus slides, so I just want to be mindful of what to present today. Go ahead and take this poll. You will have 2 minutes for this poll. So there are no right or wrong answers. We are not going to judge anybody on this. So we just want to have where the audience are placed before I get started. Should let me know when people are
Yeah,
ready.
we already have 12 responses, so we should be very quick.
So how many participants do we have today?
At this point, we have 18, but we expect this to
Okay.
go up. So,
Okay. So maybe we can present the poll results.
yeah, just
Let me stop the share.
uh, uh, maybe some people just don't want to take it because they don't use the sidereal zodiac. So I will end the poll so that we have a rough estimate of where we're
Okay.
headed.
Okay. Sure.
So Chitra Paksha, Lahiri, and KP is the dominant, 62 percentage.
Okay.
And
Just a minute.
Raman is 31 percentage. I have not answered, so I use Raman, so you can count me. Pushya Paksha is,
Okay.
yeah, that's it.
So are you presenting the results or?
Yeah, I'm telling you the results.
Okay. Sure.
Can you
Chitrapaksha.
see? I don't know what is happening, but are you able to
Yeah,
see
I am
the?
able to see. I am able
Yeah,
to
we
see.
can see.
We can see that. Yeah, yeah.
Okay, so the first question is which Ayanamsa you use most frequently, for which we have Chitra Paksha.
Okay.
Um,
Paksha. Okay.
yeah, and how did you arrive at your
Okay.
current choice? Is suggested by my guru. Uh, that is predominant. And what are you interested to know more today? Astronomy fundamentals, comparison of existing systems, and solution to the
Okay.
Ayanamsa problem. So it's above all, basically, that is leading the show. And
Okay.
what is the correct position for a star astrologically? I don't know is a very prominent and common answer. So I
Okay.
think you know
Got it.
where to take it at this point.
Yeah. Yeah. Got it. Good. So we got a good feeling of where the audience are. So I will get started with the presentation. Just give me a minute.
Sure.
Okay.
So
Let me
would
share
you
it.
like to take questions in the middle or towards the end?
We will have probably I want to divide it into three sections.
Okay.
So probably we will do 20 minutes each, 25 minutes. Just
Okay.
keep a clock for me. So, and then I want to dedicate more time for the Q&A. So that's where it's going to be interesting. So I will try to rush through. I have a lot of content,
No
but
problem.
I will be also mindful. If you cross the time, then just let me know.
Okay. Thanks.
Um, sure. I'm not going to look at the screen, so you have to help me.
Yeah,
Cannot,
we are here. Don't worry.
okay. Just a minute. Just a minute. And I'm trying to project it. My Zoom window has gone somewhere. I'm just trying to locate it.
Okay.
Okay. So, you can see my screen, right?
Yeah, we can see.
Yes. Yep.
Okay. Sure. Today we will first begin with introduction to a small astronomy software. Most of the astrologers, they don't try to understand the astronomy behind. So whatever being taught in the books, so they simply follow it. If you want to be a very successful astrologer who is pursuing the path of scientific approach, you need to really understand the astronomy behind. Interestingly, all the whole astronomy is developed to understand how the different celestial bodies influence human life. So that's the whole purpose of building a, a mathematical solution on top of astronomical data. So if you are not familiar, this software is called Stellarium. It's a free software. You can download it from stellarium.org. And in this software, you can go ahead and explore about the different celestial objects, be it stars, be it planets. So all of that you can explore with this. And there are quite a bit of educational material available online about the Stellarium software and how to use it. So if if you're new, just go ahead and explore about this software. And this view, what you are seeing here, is basically you are staying well way behind all the stars and all of that. And then from that perspective, you are looking at Earth. So that is how you have to look at this. And then we are placed on Earth from center of the Earth when we look at it. So basically, this is a mirror view of what you would see here. And there are quite a bit of settings here. So you can go based on wherever you're located. You can choose a location for yourself. Here I have chosen like 0 point Central Africa, which is basically 0 degree lat and long. So this will happen somewhere in the sea here. For our class purpose, I'm keeping this as the location, but you have option to choose any of the locations that you want. And then you can choose the date and time. So the astronomy software made it easy for us to go back and forth in time. So that way you can go look at where planets were located at that particular point in time. And you have different viewing options. This is very technical. I won't go into it, but whatever is required, I will cover that. And then you can search for specific objects. So either a star or planet, whatever you want, you can search for it. And then you can configure what you want to show, which information you want to show, all of that you can configure from here. I have chosen few defaults. You can add more. So if you add more, the screen will look cluttered. So ideally you should keep it minimal, whatever required for you. And then you have calculations window. This is basically to see when eclipses are going to happen, which planets is moving where, and all of that. And then this is a help window available for you. When time permits, I would request you start exploring this tool. This is a wonderful tool, I would say. Very easy to understand and use. Please explore this. And in this tool, if you go in this tool, you have the below options. You can move it forward. Basically, it moves by clock. You can go back and put it in any time frame you want. You can show the different grids you have. So basically, this is the equatorial grid. So if you put an equatorial grid, basically, which is similar to the equator. So equator will be the center, and then from there, north and south, you will have grids. And this is called ecliptic grid. So ecliptic grid is based on the axial tilt we have. So if you look at here, both tilts will have different, portion on the north. So this angle is the 23.4 that we have. So these two grids intersect at a particular point in time, so which is the equinox day, spring equinox day. So when they come together, there is one particular point, 0 point, both of them will intersect. So we will talk all of that in the future. So this is just to give you an overview of the software. Okay, so we are going to primarily use this software for a few validations. The objective of this session is not to provide very detailed one, rather help you initiate in your journey towards understanding Ayanamsa, so that you can go validate yourself. You don't need to trust whatever I say. You can validate for yourself, and then you can find out the most appropriate Ayanamsa for you. Sure, let's get started now. So we will begin with very basics. There are two calendar systems, Julian and Gregorian. Ashwin, you can mute others if you want.
Yeah. Okay.
And this is mainly coming from where we have 1582 CE Common Era. Till then, the world followed Julian system, and after that we have Gregorian system. Whenever you calculate any Ayanamsa, you need to take into account till 1582, you have to calculate based on Gregorian time frame, and then prior to that, you have to calculate based on Julian time frame. So we will often come across anchor years or base years as like 285, 399, all of that. So when you do the calculations, you want to calculate annual movement. So you have to take two different time scales that you need to consider, and that is a cutoff point for you. And then let's get started with tropical and sidereal. Today's focus is going to be mainly on sidereal system. Again, there is nothing right or wrong. So both systems follow a different approach. So in tropical, the Ayanamsa, there is nothing called Ayanamsa. Every year, when the new year begins, when the equinox begins, that is when the new year starts. So there is no underlying star framework in tropical system. So everything is just based on seasonal movements. So that is the basic difference between tropical. And when it comes to sidereal, sidereal primarily considers the nakshatras, 27 nakshatras, as the second layer um, um, for calculating Ayanamsa. So when two practitioners talk, one from tropical and sidereal, they need to understand the basic difference. Basically, the reference point is fixed in sidereal. In tropical, it is very dynamic. We are not going to talk much about tropical today, but this is the difference. Wherever needed, I will highlight it. So if you cast two charts, one based on Western chart and then one based on an Indian style with Ayanamsa, you will have charts like this. This is a South Indian style chart where you have the Lagna ascendant, and then you have other planets shown here with few mathematical calculations like Hora Lagna and all. So the one thing I want you to take a careful look at is here is, if you see here in Western chart, you don't have something called Ayanamsa. It's called a no Ayanamsa. But if you take Indian chart, so this is based on Chitra Paksha Ayanamsa. So this is when we had a particular point in time. So this chart is calculated for that one. Okay. So this is the basic difference you will see. Because you are deducting 24 degree from this, you will see that always in Indian chart, every planet is moved a little bit backwards compared to what we see in Western chart. So that's the basic difference. Because some of the planetary positions could drastically change, all the interpretations coming out of the Western and sidereal systems will be very different. For example, in this case, if you take Chandra and Rahu, so here if you take in a Western chart, so they are basically placed in Meena Rashi, Pisces, but here they are based in Aquarius. So that's how it will go. And then here in Western chart, the Mercury is debilitated. Here also it is debilitated. So there will be some changes in planetary positions. If you see here in Western, Jupiter is exalted, but that is not the case with Indian chart. So these are the basic differences. Whenever someone talks about any astrological framework, the first statement they need to make is which system they are talking about, because the underlying maths are very different. And then the basic, at a very high level, the astronomical basis is there is something called an axial precession, where when the Earth rotates, it slightly moves due to axial precession. And then this cycle, it takes it for one rotation, it takes about 26,000 years. And because every year the vernal equinox slowly happens a little bit earlier than the previous year, every year there is a small shift. Western astrology anchors its calculation based on the moving equinox, but Vedic astrology uses fixed stars. That is the basic difference at a very high level. If you look at the time frame, when you take a 285 common era, that is when both systems were similar or they aligned together. And then from there, when you look at here in 2026, So the axis drifted by 24.18 degree. So that is at a very high level interpretation. Now we are going to look at it from a more detailed view, mainly looking into sidereal system. So when it comes to sidereal systems, it's not just about one system, rather there are multiple systems involved here, and there are different proponents for different systems. So one question we asked about is, how do you decide the merit of an Ayanamsa? So many people suggested that based on their teacher suggestion they follow. We have to understand that Ayanamsa is a hardcore astronomical concept. It is part of it's not part of Hora, rather it is part of the Siddhanta. So Siddhanta Skantam, when it comes like that, so it's all about astronomy. It is not anywhere related to predictive part of it, basically the interpretation part of it. So if you have been deciding the merit of the Ayanamsa that you follow, because it suits your chart or someone's chart, you should actually change your perception towards it, basically, because Ayanamsa is not about interpretations, it is all about astronomical merit. Okay. And then here I'm presenting you two different Ayanamsa for you. So one is based on B.V. Raman Ayanamsa, the other is based on Chitra Paksha Ayanamsa. So this software is Sri Jyotish Star Pro. I have a version 9. We are also going to look at another software. This is just to give you an idea for that. So if you look at here in the Ayanamsa part here, you will see B.V. Raman says 2246. In Chitra Paksha, it says 2412. Within Indian or sidereal system itself, there are different proponents, and then they propose different values. So what kind of impact it can have on the chart is, if you look at here, interestingly, in this case, no planets have moved houses. But because there is a difference of about 2 degree, 1 degree and something, some planets could move their placement. So let us take a specific look at on a particular date on 2024 equinox. So this is a little bit old data. That's what I had. I will explain that about you. If you take tropical system is called a Sayana system. And then if you look at here, sun is just entering Aries, 0 degree Aries. That's what I have taken here. For the same low position in time, if you take different Ayanamsa schools, Lahiri will give you 5 Pisces, 48. And then like that Pushya. If you look at here, each Ayanamsa will give you the planetary position a little bit differently. So let's get in a little more detail. So if you take true Chitra Paksha as 0, as an index, and then if you look at Lahiri will have a lower number, Pushya has a higher number, B.V. Raman has the highest difference compared to Chitra Paksha. And Rohini at 15 degree or Chandrahari system, they are lower than what the position through Chitra Paksha Ayanamsa. So this creates some amount of confusion. What kind of impact it can have on the chart is, so basically the planetary position could change if you say different Ayanamsa. So here we have taken only sun's position. And then based on that, if you look at, you can see the different values here. And then the second impact it can have is, similarly, if you take a moon's position similar like this, because moon will also have the same difference in degree between the systems. So if you take that one, see here, you will see in true Chitra Paksha, if you keep as a base, in Lahiri, the Dasha Bhukti will change from 3 to 9 days. The highest difference will be 235 to 783 days based on which the Dasha you are running. If it is Sukra Dasha, if you use a Lahiri versus a Raman Ayanamsa, you will pretty much see 700 and almost like 2 years of difference in Dasha Bhukti. And in Raman Ayanamsa, all the periods will happen earlier than compared to true Chitra Paksha Ayanamsa. And these are the differences. Similarly, in Rohini, the Dasha Bhukti will happen prior to Chitra Paksha. So those are the changes you can see. So this creates a lot of confusion, because when you are coming to predictive astrology, different astrologers use different Ayanamsa. So they are going to predict the events differently. So that is going to create confusion for the for the people who consult with us. So this is a long-standing problem in Indian astrology, I would say. The next most important effect it can have on is, so in Indian astrology, if you go through Parashara system, we have something called divisional charts. So divisional charts provide, there are 15 divisional charts additional in addition to Rasi chart. So if you go through each of the chart, those divisional charts are basically transformed view of the Rashi chart. So when you calculate divisional charts which are very defined at a very smaller level, like Shashti Amsham, the divisional D60 chart, same planet, if you see through Chitra Paksha, Sun is exalted in this chart. If you use different Ayanamsa systems, you can find that Sun goes and sits in different places. And similarly, the Lagna will also move. If you are going to interpret about somebody's past karmic, past life, previous life, if the sun is placed differently, then the interpretations will be very different. So it creates a lot of confusion and then a lot of ambiguity. So using multiple Ayanamsa is also one of the major problems any serious practitioner will come across, and that leads to a lot of variations in predictions and outcomes. So these are the challenges. I will take the quote from um, Reverend PVR Narasimha Rao in 2005. So this discussion was very active, I would say, from 95 to 2010. This Ayanamsa discussion was very active in social media at the time through the Google groups and all of that. So Chandrahari made a new Ayanamsa, and then he proposed that Ayanamsa, and then there is a discussion between Chandrahari and Narasimha Rao. So he comes with this kind of a statement saying that anybody who is a little bit intelligent, who understands astronomy, can come up with an Ayanamsa system, and then they can defend it. And every system has its own merits, and it's always very difficult to find out who is right. So this ambiguity in using the correct Ayanamsa continues. So that's what he concludes. Now, just to put in summary, so what kind of implication it have is basically if you use a tropical versus sidereal, the whole planetary position will change. If you use within Ayanamsa systems, the degrees will change. So because of that, if you are going to take Dashabhakti timings, it is going to have an impact. The second most important impact is on Muhurta selection, especially when you want to decide about an appropriate Muhurta for a specific event. If you don't use the correct Ayanamsa, then your Muhurta timings are not going to be correct. So that is another impact. So when two practitioners from Western and sidereal system come together, so what they need to understand is, instead of criticizing each other, you need to understand that both systems follow a different measuring tape. And because measuring tape is different, one is like metric, one is like, the old system. So both are basically talking the same. Both are talking a same concept, but in a different language. In Western system, the concept is mainly revolving around the zodiac, 12 zodiacs. In Indian system, it goes one level beyond. It goes to the next level, which is the 27 nakshatras, and even further to 108 padas. So these two systems will never be same, and these two systems, there is no need to make a judgment that this is good or this is good, right? Sure. Let's move on. So we talked about the problem. Now we are going to talk about, are there any solutions? So who is correct in the current system? And then is there a way to make it better? So that's what we are going to see. So I want to talk about the current approach about Ayanamsa. So when somebody says about Ayanamsa, they will always talk about a few points. So they will say this system is based on a particular star. And then they will tell this star position happened on particular date and time. And then they will tell this nakshatra was placed on this particular position. And then they will also talk about from that year, if you take current time, so every year it is moving by some 50 plus arc seconds. So these are the four items, 4 data points they will always talk about when you come across any Ayanamsa. Any Ayanamsa that doesn't have these 4 components is not a scientifically valid Ayanamsa. So there is no astronomical merit. If somebody wakes up and say that God came in my dreams and he suggested that this is the best Ayanamsa to use, you can just discard those kind of arguments. Okay, it's a hardcore astronomical subject, and its merit has to be decided based on astronomical. So let us move on. This is the current approach. So based on my investigation, what I find as the gaps in the current approach. So there are a few things I want to consider additionally. The fifth point is there are about 27 nakshatras. If you take the 27 nakshatras, they are actually not 27. Rather, there are a few nakshatras defined as clusters of stars. For example, Kritika. Kritika composes of 8 stars. It's not about 1 star. If you take Spika, Spika is considered as 1 star. If you take Mula, Mula has about 9 stars. So when you have multiple stars, right? So, and not all the stars are placed on the same position. We are going to see that. So which star should be considered as the anchor star? So people talk about a specific Yoga Tara and all of that. Yoga Tara is basically the second aspect of astrology, basically predictive astrology, where you talk about that. But when it comes to astronomy, there is nothing called a Yoga Tara. The star cluster itself should be considered in full. Currently, none of the Ayanamsa schools talk about that. And then the next important part is any Ayanamsa school will always talk about a single star, at best 2 stars or maximum 3 stars. They don't talk about the entire 27 star system. They don't talk about the Kalapurusha principle, whether your Ayanamsa also fits in the Kalapurusha principle. That they don't talk about. Then the third important aspect is there is an identification defined for each of the 27 star groups. Whether astronomical position and astrological position, is there any correlation between them? So nobody has gone into that kind of a detail. In my opinion, based on my investigation, what I realized is unless you also bring in the astrological framework on top of astronomical data, there is no solution towards a good Ayanamsa. So there are a lot of questions involved when it comes to Ayanamsa, making it a very complex topic. Basically, complex stellar movements, different objects move in different speed and different directions. And people always talk about the importance of equinoxes. And then current calculation methods, there is no clarity on what is a correct position for a star. For example, Chitra's position is defined as 180 degree, and astrologically it is defined as 173.33. So which is correct? People tend to believe 180 as the correct answer. Is it correct? We are going to look at it. And then beyond the current framework, how can we bring a scientific statistical rigor into this astronomical data to figure out what is the correct Ayanamsa? That is what we are going to see. And then the question arises, what is the Ayanamsa, good Ayanamsa in the past, present, as well as in future? And this is very important, especially when there are 2 stars, Chitra and Swati. So currently, if you look at it, they comply with astrological sequence, but in future, in a particular point in future, Swati will move ahead of Chitra. So when that happens, the whole astrological definition of the 27 nakshatra framework itself is going to break. So what will happen at that time? So those are the things I want to cover today. I will try to rush through quickly. So anyone who wants to learn more about astronomy, or if you might have come across some of these references, if you are familiar with the topic, These are some of the English language content. Popular, I would put them as popular because these mainly meant for a general audience. There are all stalwarts shown in here. So you're taking from Ernst Wilhelm. You have PVR Narasimha Rao, you have the KRS channel, and then Sanjay Rath, all of that. So you can go explore them. So they present a particular view based on their understanding. And in this whole of this, I would say Ernst Wilhelm's is more data-based approach. So this is popular. So if you want to really get into a technical content on Ayanamsa, so this is from the astro.com, basically the Swiss ephemeris website. And there is this link is available for you. Specifically, go to this 2.8 section on sidereal ephemeris for astrology. It's a very large section. You can go one by one. You can read about individual Ayanamsa schools, how they have validated it, how it is calculated. All of that it's given. It's one of the treasure troves, I would say. I have extensively referenced this in my Ayanamsa works. And this concludes with 5 different schools of Ayanamsa, basically based on some nakshatras, either Rohini or Spika or Revati or Pushya or Mula. So those are the 5 Ayanamsa schools it talks about. Now we are going to, after this background, we are going to talk about the solutions towards Ayanamsa. So we'll get into understand the astronomy behind. So you all maybe, as you all know, so when Earth so makes an orbit around Sun, it goes through 3 different kinds of movements. One is the self-rotation. Every day we call one day one rotation. And then it comes around the orbit that makes in 1 year. These are 2 well-known rotations. The third rotation is something called axial precession. Axial precession is because Earth is tilted on its axis by 23.4, 23.5 degree. So when it makes an orbit, it makes something called a rotation on the top of it. Because of that movement, every day the rotation happens. If you use based on the system you use, if you use nakshatra as a base, the nakshatra sidereal day happens earlier than the solar day. So we are going to talk about that. So these are the 3 rotations. So this visual gives you a good understanding of it from a visual perspective. If you look at the Earth, so this is how it rotates, and then this is how it rotates when it moves around the Sun. And this rotation is very, very minor, very minute rotation. So if you take 1 arc second as 1.1 by 3,600 degrees, so every year this movement happens by 50.3 arc seconds. So if you take about 72 years, so this movement will make into 1 degree. That's why you see every 72 years, the tropical system changes its beginning point by 1 degree. Its zodiac moves. That's what we call dynamic. And if you take 1 degree in 72 years, for completing 360 degrees, it will take about 25,000 years. So that's the concept. And there is also something called nutation. So along with the precession, it doesn't happen like an exact round here, because Earth travels along with the moon. There are 2 body systems. When they move together, both influence each other. Both of them go through something called nutation. Nutation is within the round itself. It will go a little bit back and forth. And this is also important to apply a concept called true node and mean node. So you should follow true node approach when you set up your software. And let's understand the diagram on this one. So if you take the round here, right? So this round here. So if you put the round here like this, so the current pole star is Polaris. If you take about 12,000 years back, so the pole star was Vega. So in the northern hemisphere, we have at least 2 stars that are aligned close to that circle. So since we have 2 stars, 2 north stars here, this is used compared to the southern system. Okay. In the software, I would always mention about something called a HIP-ID. HIP-ID is the scientific, one of the IDs you can use to identify a particular star. Okay. So the Ayanamsa puzzle, if you take, it consists of 5 components. The first one we talked about axial precision. Then we are going to talk about vernal equinox. Then we are going to talk about the coordinate system itself. Then we are going to talk about sidereal, the 27 nakshatra system. And then we are also going to talk about the complex planetary motion. So we'll go one by one. Are we good with the timing going well? Ashwin?
Yeah, we still have 1 hour and 10 minutes, so no problem.
Okay, sure. So 2 coordinate systems. So earlier I showed you about the coordinates, right? So there is an ecliptic coordinate, there is an equatorial coordinate. So if we use a equatorial grid, so you will see, when you see in the sky, you will see like the planets moving around this path. So this is when you keep the pole star as the top of your grid system. Okay, and then to understand ecliptic, so ecliptic is, this is when you are on Earth, you see the sun, and then when you track sun's movement, basically you are moving, sun is relatively fixed, but you are keeping yourself fixed, and then you are thinking sun is moving, and then if you draw an imaginary line, so that is called the ecliptic, right? So that is the ecliptic line. Because Earth is tilted on its axis, so it would have a different grid system. If you put the ecliptic, you will have the precision circle coming. The pole star won't be on top, rather the pole star will be on this line, aligned on this line. You see, close to Abhijit is located here. From this view, you can see that all planets will travel through a straight line in the ecliptic grid. Okay, and so we call ecliptic path. So the ecliptic path is about 9 degree plus or minus the 0 ecliptic. So this is where all the planets will travel through on different lat and long over a period of time. So that is a scientific understanding. This one we saw earlier, the equatorial and equatorial view, we are keeping the pole star at the top, and then in the ecliptic view, we are keeping the pole star on the little bit of the periphery of this circle. Okay, and if you look at in the ecliptic, the green line, 0 line, it will be in the middle. If you look at here, this will be a little bit tilted in alignment with the Earth's axis. Okay. So because Earth is tilted on its axis, and the tilt is also not fixed, it changes over a period of time. I'm going to show that. Because of that, every year the system, the grid system, the ecliptic grid keep moving away from its original placement sometime in the past. So to fix that problem, there is something called International Celestial Reference System. So this was adopted in 1998. So what they have done is, instead of taking every year movement in ecliptic, so they have taken very far distant objects, like hundreds of distant immovable quasars, well away from our galaxy system, several billion light years away. So they are using them as to decide the coordinates for the ecliptic system. So that's the latest addition they have done. So this is in effect, we call something called J2000 standard. So J2000, whatever happened during the equinox of J2000, so that time they've taken as the framework, reference framework, based on which all the calculations are made. So this help us avoid the moving ecliptic grid over a period of time. Okay, and then this is about the fixed reference. Okay, so now we are moving to the stars. So sun, you may be aware that sun is a single star system. But if you take most of the stars in the open sky, we can see about 6,000 stars, 3,000 stars above northern hemisphere, around 3,000 stars in the southern hemisphere can be seen with the naked eye. So it has something called a visual magnitude of plus 6.5, any object plus with the 6.5 you can see. If you closely observe any of these stars, you will notice that there may be stars with more than one star, which is two-star system. So this is how they will move. And then there is a three-star system. And then there is also a four-star system. There are also more number of stars involved in one star. For example, if you take Spica is a double star system. For us, it looks like one nakshatra. Since it is located far away, like 300 plus light years away, it looks like one nakshatra based on, if you closely observe, there are two stars involved that move around each other. Similarly, many of the stars we use are have more than one star. There is also something called a pulsating star, variable star. Those are astronomical terms. Sometimes it will look bright, sometimes it will look dull. There is recently you might have heard about the Ardra Nakshatra going dull, all of that. So that all happens because it's a variable star. So this you have to understand. Now let's get into understanding the 27 nakshatra. So this is called Mercator projected view. Just the way you see in a flat round globe, you see in a rectangular shape. So that is a similar view I have put here. I have taken all the 27 nakshatra group data. I have placed it over the latitude and longitude. And then this is sidereal, adjusting all the position to keeping Chitra at 180 degree. So this is how it will look like. So if you look at here, there is a 6-degree band that you need to understand on above and below. So here on this 6-degree band only, most of the planets will travel. You will often hear about moon hiding a particular star, right? So all that happens only with these stars. Moon can never go and block Hasta Nakshatram or any other nakshatra below or any other nakshatra above. Because this 6-degree, how it is arrived at is, Earth is coming with an ecliptic, and then Moon is placed 5.5 degree angular to it. So when these two interact, so that is how you get the 6.56-degree band here. Interestingly, all other planets also travel this path. If you look at here, Revati Nakshatram is just exactly placed on the line. There is Chitra is a little bit south towards this zero. You see Pushya exactly on the line. And then there are few nakshatras within the band like Rohini. So if you look at any of the Ayanamsa, either they would be based on Revati, Chitra, Pushya, Rohini, and there is also Mula Nakshatra based Ayanamsa. We'll talk about a little bit more about this. Now let us understand how far these nakshatra are placed. Not all the nakshatra are placed equally. So here I have given you the reference IDs. For example, Ashwini comprises of 2 stars. So I have given their scientific ID. You can later review it. If you want to validate, you can take this data, HIP data, and then you can locate the particular star. So if you look at here, different stars are located at different distances from Earth. But when we see from Earth, we get to see all of them as a flat, round, circular view. So we are using a compressed view, not a 3D view. Rather, we are taking a 2D view of the stars to find out the planetary movements. The closest one would be the Shravana Nakshatra. There is one star which is like just 17 light years away. And then there is in Mula, if you take the Mula Nakshatram, the last star, which is about 1900 miles, 1900 light years away. Average is 303 light years. Chitra would be around this range. So you can see that here. So what you have to understand from here is, the farther the nakshatra is placed, for us, it will look like it's not moving at all. If a nakshatra is close to Earth, it will move. It will be subject to more movements. So now let us understand how Kritika moves, just to get an idea. So Kritika Nakshatra Pleiades group. So that's what it consists of 8 nakshatras. If you take this star, you see over a time period, they have given an axis. So they are showing how this star is moving. So this is the star cluster. If you look at here, you can see that moving on different distances with each other. So that's how the cluster moves. When sun moves, all the nakshatras along with it also move in that handle, right? So that's what you have to understand. Now let us understand movement of one particular nakshatra. So every nakshatra is moving, but every nakshatra is moving at a different speed and in different direction. So if you consider the expanding universe, so if you see it's like an expanding universe, every star moves away, farther away from the center of the universe, right? If you take what is called a barycentric view, basically take sun as the center. If you look at the star, every year the star moves away from it, right? Some stars move away, some stars come close, also, that is also possible. And then if you take two extreme sides of the 6 months distance, so one, the star could look a little bit on the left side, the star could look a little bit on the right side, and then there is also equinox. If you take in the center of the equinox at the time, the star will look on the middle. So there is a sideways movement, and then there is a movement towards away from the from sun. So that's what happens every year. Every year it moves away, far away. The we call proper motion is more than parallax motion. When parallax motion, if you observe the sky, if you take the planet, if you take the star position, that number will keep changing. So that's what you have to understand. So now let's come to understanding the movement of, why the equinox is important. So we are going to talk about Uttarayana and Dakshinayana. In all Ayanamsa calculations, we always use Uttarayana equinox. So that's what we are going to understand. So this you must be aware, Earth is tilted on its axis. So 23.43 is the axis. So if you draw 23.43 above, that is where you have the Tropic of Cancer, below is Tropic of Capricorn. So that's what you know. And then landmass, if you see 68% of the landmass is on the northern hemisphere compared to 32 on the southern side. And if you want to understand solstice, June solstice is when sun travel to the farthest of the north, where the daylight time will be more in north. Similarly, when sun travels towards the southern hemisphere, at the maximum point here, you have the winter December solstice here. Okay, and so there are that's the movement. Ayana means path, moving path. Here, when we talk about Ayana, we talk about movement of sun. So let's understand this. If you take sun like this, just a small graphic, on equinox day, it will travel over the zero equator, right? And then if you take its movement, it goes towards south, winter solstice, then goes up, goes down. So this is how every year sun moves, right? And then I tilted the earth. Now, if you look at it this way, it goes through like a corkscrew, the screw pattern. It goes up and then it goes down like the same way, right? So that's what you have to understand. And because it is tilted, based on the tilt, so these 2 points on this tilted axis, so they will have the sunrise during the same time. So even if you are placed on the same latitude, the sunrise time will be different for you because of the tilt. So this is the central part. So if you look at 0 point and Greenwich is north of 0 point. So it will have a different time for sunrise and vice versa. So that's what you have to understand. You see here it happens at 3:04, it happens at 2 minutes later. Okay, so let's understand about the long-term impact. So if you understand about Earth's axial tilt, it's not fixed. It goes through a cycle with a band of 22 to 24 degree. Currently, if you take 18,050 CE, that is a 0 point. So right now we are in a path towards the tilt Earth just little bit lifting itself so that it comes from 24 to 22. This tilt has, the mean period, one full cycle, it takes about 40,000 years. So let us understand this a little bit. If we take equator divided into two lines, Tropic of Cancer, Tropic of Capricorn. So if you put it at the center point, so if you take the height of Earth, which is about 12,700 kilometers, on each side, sun travels from equator, it travels north of 5,200 kilometers and south. If you take from sun's distance, the Earth, which is about 12,000, 11,000 plus, size of the Earth is always is how far the sun is placed. So there are some numbers, 1 degree, how much time it takes. If it moves north by 1 degree, it travels about 110 kilometers. So these are some of the numbers for you. So when sun is just above your latitude, that is when you have no shadow day. So there won't be any shadow for you. So that would happen on the day. Okay. So because the Tropic of Cancer and Tropic of Capricorn are moving, when it goes to the lowest point, the current Tropic of Cancer will go southwards by 155 kilometers. That's what you have to understand. Why I'm talking about this is, so because this angle is changing, when the angle goes down, that is when you will have something called an ice age. So when ice age happens, most of the ice will go and form in the northern hemisphere. The sea levels will drop. All of that will happen. And then the last ice age is when we even talk about the modern era of humans. That's when it begins, right? So if you look at here, so this here, it's approximation. This is where the sun will travel. Earlier in the white band, till here you had ice. Why I'm talking about this is when ice age happens, the top and bottom of the earth, right, poles will become very heavy because it will accumulate miles and miles of ice, mountains of ice. And then the middle portion of the earth won't have water, less water. So the entire wobbling speed and all of that are impacted because of these ice ages. It happens for a long period of time. So currently, if we take 2000 as the middle year, so we are going towards the minimum, going towards the ice age. So probably in 8,000, 10,000 years, ice age will happen. North side of Canada, all those countries won't be there at all. It will be all covered in ice. So that's just a little bit of astronomy and geological changes. Okay, so just to summarize, the I hope some of you may be aware of the Milankovitch cycles. When Milankovitch cycles talks about long-term movement of planets around Sun as well as the axial tilt. So currently the Earth is moving closer to Sun in its orbit. This because of this axial precession, this cycle can change over a period of time, 21 to 24 degrees. Just that's about the understanding. So now we will come to daily impact. We talked about a long-term impact. So let's understand what is a sidereal day and what is a solar day. So if you take, these are basically two different scales. Every day, if you fix a particular time in night, like 8 o'clock, and then go and look in a particular point of in the sky, you will see that the stars will come to the place 4 minutes, almost like 4 minutes earlier than the previous day. So every day, the sidereal day happens 3 minutes, a little bit earlier than the solar day, right? So that's the difference between a sidereal day and solar day. In sidereal day, you keep a star as the fixed reference. In solar day, we keep sun as the fixed reference. Sun is close to us, stars are far away from us. Because we use a star far away from us, but because of the Earth's rotation axial tilt, that happens a little bit earlier. This understanding you should have. Every year, the equinox happens 20 minutes, 24 seconds earlier than the previous year. Every day, 4 minutes earlier. In one whole year, it happens about 20 minutes earlier, the equinox happens. So this is a basic difference. When Western system anchors it based on solar day, the equinox, so their equinox, their whole years happens earlier. In the 365-day cycle, that happens for solar day. If you take sidereal, by the time Earth rotates around 366.25 days. So those are the differences you have to understand. So let's understand the picture below. If you keep sun and earth, sun and a star on a fixed point, if you take a sidereal day, you can see here that the star comes to the same spot. By the time Earth completes one orbit, it comes 3 minutes, almost like 4 minutes prior to sun. The sun will come to the part only after 24 hours, but the star will come earlier than that. Because of that, you will have one more day, solar day, sidereal day compared to solar day. So this is the basic definition. So when we talk about Ayanamsa, so we want to go back in time. So we want to fix a particular date and time and keeping the star, the sun, and the earth in alignment. And from there, so we want to calculate the annual movement. So that is the underlying principle for this understanding this Sayana versus Nirayana system. Nirayana is Indian sidereal system. Sayana is the Western system. Okay, every year, it moves around 50.2 arc seconds. Okay, so let's a little bit understand about, visually this one. Let us take any year. Okay, so any year we are taking an equinox day. So we'll keep the earth on that particular part. So we will keep star and sun on the particular part, right? So when the earth tilt changes, goes like that, it changes its ecliptic axis, the tilt. So when it changes its tilt, so you see here earlier tilt change now. Now if you look at here, the nakshatra day happens first. After that, the sun solar year happens. Nakshatra year happens first, and then happens the solar year. If you take one more year, you see it happens a little bit later, right? If you take one more year, so over a period of time, the solar year happens a little bit later than the nakshatra year. So that's what the difference is, what we call as Ayanamsa. Okay, so let's understand it a little bit from the software side. I will switch to the software now. I will show you the actual, how do we set this up. So if you look at here, there is something called equatorial line, zero line, that line. And then there is called ecliptic of date, ecliptic latitude, longitude. So both of them meet at a particular time, 0 degree. If you put this one 0 point for, the 0 lat and long for this date and time, you will find that sun is exactly placed on the 0 degree, right? So I'm just turning it a little bit. I'm showing you here. So sun is placed exactly on the 0 degree, and then you have both ecliptic and equator intersecting this. So this is the basic fundamental for defining an Ayanamsa. When you say any Ayanamsa, you should tell on this particular equinox date when sun is at the intersection of the ecliptic and equatorial grid on 0 degree, where a particular star is located. That's how you will define any Ayanamsa. Okay, you see here, sun position I have taken here. It is sitting exactly on 0 degree. North, did not go to north, it's just exactly on 0 equatorial. And then you can see the equatorial line here defined on RA declination, that is also on 0. So that's how we define a Ayanamsa here. You see here, but if you take Indian system, right? So this is the situation. We are talking about same year, 23, 20, 26. But if you take India, the new year, actually, we say the new year began on 14th of April, right? If you look at here, this is not happening at 0, right? It is happening almost like 23, 24 degree away from the center, right? 0 degree. Why we say it? Because based on our historical Ayanamsa year, this happened in earlier. Now, because sun's axis has moved, so we are keeping this as the beginning of the new year. Basically, we are referencing to old time for as the base for us. So this is the understanding. So now let's take Earth's rotation. Normally, Earth axis, I told you, right? So Earth axis keep on changing, and then that axis change also get accelerated because of various reasons. One is the influence of Moon. Moon travels close to Earth, so they travel together, they impact each other, they are on a tidal lock. So movement of Moon can impact the axial tilt of Earth. Similarly, all other planets, when they are all aligned on one side of, on the opposite of Earth, or when they come close to Earth, all of the planets come close to Earth, that's when they can change the axial tilt to a little bit, they can make an influence on that. And then we also have something called the Van Allen belt. So magnetic field, all of that moves. And we talked about ice ages. Ice ages can change the whole geology of Earth, impacting its long-term movement. And then we also know about mining activity by humans. That also contributes to the change in the axial tilt, very mild, but over a period of time. So if you take any Ayanamsa calculation, they will use a fixed value. For example, 50.3 degree movement, 50.3 arc second every year. That is what is a standard practice. But because of these reasons, it is not technically correct to use a one particular fixed value. Rather, you have to calculate it dynamically over a period of time instead of keeping a fixed value. That's the point I want to drive home from this. And then let's talk about why we are hell-bent on equinox day, right? So let's take 3 objects. So Earth is a moving object. Sun is also a moving object. We'll come to that. Compared to that, the stars are relatively less moving object, right? So when we take a equinox day, so what happens is, here if you see here, the arrow here, basically the Earth goes up and down south because we are observing from Earth. It looks like Sun is moving, but basically the Earth is the one actually moving. That's why I put the arrow here. And I showed an arrow here that it includes proper motion and parallax motion. So if you take a view from center of the Earth, when Sun will happen is it will happen only on equinox day, either a winter equinox, either a spring equinox or autumn equinox. Those are the time when Sun will come exactly on 0 degree. And then if you take a different point in time, so Sun could be moving on either north or south, and then that could influence, if you draw a scale here, if you take a different point in time, it could point to different, degree of the star. So to avoid it, you have to keep it in the middle of the Sun. And then there is also distance of the star. If you consider a far distant star, it will be prone to less minimal movement. You'll understand it when I put it here. You see here, if I use a closer star as anchor star, it could be subject to more sideways movement, right? So to avoid it, so we always take the equinox day as the base for any Ayanamsa. And then coming to Sun's movement, you know something about barycentric motion. All the planets don't come around Sun, rather, including Sun, they move around a common center that is called barycenter. So this is how Sun also moves over a period of time. That's why we call Sun as a graha in astrology. It's technically correct because graha means something moving that is not fixed, right? So if you take Sun's movement, the same thing is shown here. Over a period of time, Sun has gone through different movement. And because Sun is moving, it is always better to keep, to minimize the movement, to minimize the error from Earth side, we keep it from the on the equinox day. One more interesting thing you need to know is on a equinox day, if you take anybody born on equatorial, on the grid, on the 0 equator, if you draw a Bhava chart, the Bhava chart will be always equal. All the 12 Bhava will be equal, right? That is an important astrological consideration because only on that day, on equinox day, for somebody born on the equatorial grid, on the 0 equator, all the Bhavas, Rashi and Bhava, Rashi are defined a little bit different length, but Bhava will be always equal. That's the reason we always correct any current data back to a equinox day so that the all bhava will be equal. So this is an important astrological consideration. So we talked about all the stars move. And then if you look at here, these are the distances, some astronomical data. So if you look at here, the star that is closer to us, you see here Swati, which is close to us, it has both higher proper motion, and then it is also subject to more parallax sideways motion. If you look at Rohini, it's more subject to, Rohini is a little bit closer, it's only 66 light years, so it is subject to more movement. So if you look at Chitra, it's about 250 light years away. If you take Moola, one of the Moola, it is very far, 1900 light years away. So far distant stars will be a better candidate compared to a star which is closer. That's why you will not see anybody coming up with Ayanamsa based on Swati, because Swati is highly subject to movements. This is what you have to understand. Now, let us look at Ayanamsa conditions. So you have to take a reference point, you have to take a equinox day, and both equatorial and ecliptic should overlap on that time. Sun should be on the spot. You should also give a reference star, and then the reference year, and then you have to talk about annual movement. Now let us look at the Kala Purusha. Kala Purusha in Indian astrology is the core concept. So Kala Purusha divides the Rasi from the beginning to the, as a head portion to the feet portion. So this is an important concept. It is, bear with me for in Tamil. So this is in 0 degree to 360 degree, 12 zodiac. So this is similar to Western system. But beyond that, if you take, we also have 27 nakshatras, and then we also have 108 padas, right? So Indian system doesn't consider only the 12 rasi, rather we are fixing everything to a particular point based on 27 nakshatra. That's the core difference we have between them. If you take J2000, the definition here at the time, if you take the grid, which is the Sayana system, you will see that Revati is placed in, somewhere between 0 to 30. Uttarattadi, Uttarabhadrapada, that is earlier than that. So in Indian astrology, we know that the beginning of a particular beginning of the zodiac always happen between Ashwini and Revati. So where it begins is the big question. So different people have proposed different stars. You understand this grid, how it moves. It can happen exactly on 0 Ashwini as the beginning, or you could move the grid a little bit anywhere. All this range is a valid range. What we need to validate is, among these different ranges, which range is best aligned with the Kalapurusha Tattva, which basically defines the placement for nakshatra within a rasi. Okay, so I just aligned it based on Chitra, keeping Chitra as 180. If you look at here, it will look something like this, right? You see Ashwini, Bharani, all of that, it goes here. And then you will also see some nakshatras are outside, or, you see here, Chitra is placed in Libra, Swati is also placed in Libra, right? If you look at here, Mula is beginning in Scorpio itself. So those are some of the challenges. We will talk about it. So what we have to understand is, astrological framework is little bit different from the astronomical framework. In my opinion, the astrological framework to develop a model came first, and then it ended up finding out appropriate stars in the sky. So this is what we see as a actual real view of Earth. But if you see the model view, a model is a more perfected view. So a model fits into a mathematical definition well. That's why we have a model view. A model view makes it easy to calculate. For example, fix different distances between rashis, fix distances between nakshatras, all that is based on a model. So basically, astrology is a model. Astronomy is actual real, right? In astronomy, if they have to choose a star cannot be planted at where we want, right? So they need to choose between existing options. So in Indian astrology, they have carefully chosen the stars. If you take astronomically and astrologically, the alignment is close to 1. I would say it's very rare to find such models. There is a close alignment, but it is not always perfect astronomically. So that understanding you have to have. So here I have shown you some reference, data points. Again, these are not, these are from references. My numbers are a little bit different. You can see that they have defined the base year, base time. They have defined. In some places, they did not define the date when it happened. They would have defined only the correction for a particular year. So I have taken from multiple resources. You can refer to this later. We will talk about some of them, as we progress. Okay. So now let us take each Ayanamsa. We will take whatever the author has defined for a particular Ayanamsa. What was the position in the sky, right? That's what we are going to see. So this is tropical, as defined, as per the tropical system, as per the Sayana system, not Nirayana. I'm not adjusting. What we are doing here is we are taking a historical point in time, and then we are going to see how these positions move, right? I'm not making any corrections. And just going back in time, whatever the data you have, I'm just presenting here. What you have to observe is, I'm going to move between different Ayanamsa, see how subtle changes happen, okay? So that's what you have to observe here, okay? Just observe. Okay, so this is tropical. This is based on Mula, last Tara of Mula at 280 degree, if you keep it. So that is what this view will look like. So understand the degree, understand the date and time frame, okay? So I'm progressing further. So this is based on Rohini. If you keep Rohini at 45 degree, when Rohini was actually at 45 degree, so Rohini is here, when Rohini was actually at 45 degree on this date, how other stars were placed in the sky, right? That's what you see here. The next one you see is Chitra at 180 degree. So this is the 285 is the base year that is used in Lahiri and in Rashtriya Panchaga. And then this is last Tara of Pushya. You see here, this is, I'm sorry, this date is, okay, this is correct. So when Pushya is at 106 degree, so this is a little bit different from what you will find in Jagannatha Hora, because Jagannatha Hora, when if you put on this particular date only, you will find the particular star in 106. We'll get there when we'll talk about it when we get there. So you see the whole movement. Here, what you have to see here is, if you put 106 degree Pushya Nakshatra, one of the stars, you see the alignment, where the alignment changes drastically, right? Purva Bhadrapada, it went to Pisces. You see Kritika fully in Rishabha Rasi. So all those changes happen here. So this is current equinox, 2024 equinox. We coming back to one time. Okay, so now we are going to look at which Ayanamsa is technically superior. We are into the second part. Ashwin, can you tell me the time, how much we have?
We still have 33 minutes.
For the Q&A session?
Yeah, towards the end of the session, we still have 33 minutes in the session.
Oh, okay. Sorry. I think I had to rush through, sorry. Okay,
No
so
problem.
let's take about Lahiri. So Lahiri Ayanamsa, one of the major complaints about Lahiri is one of the most popular Ayanamsa used by most people, I would say. And one of the complaints about Lahiri system as critic is, so they have adjusted this particular degree 23 point. They used a particular date in time, so which is it's a Narayana based system. So they have taken the equinox of 285 as the base, and then on particular 21st March, they adjusted to 23.15. So just so this is the this value has been artificially forced on the system. It is not actually astronomically fixed, because when the calendar committee was formed, so different cultures, different society within India, they were following different calendars. Just to bring all of them together, a decision was made to fix the value of Ayanamsa at this on particular date, right? So this is not astronomically justified. The authors, Lahiri and the committee, the calendar reform committee, they've clearly mentioned that. So this is not based on any Siddhanta, rather this is based on practical utility, we want to align everybody on same timelines. So that's why they fixed the value to 2315. So this is a little bit different from astronomy, but still this is, I would say, one of the closest. Okay, so there are different schools of Ayanamsa. If you take CP, True, Chitra Paksha, Lahiri, KP, Devadatta, all of them follow Chitra based. Revati based are Surya Siddhanta, we have Usha, Shashi, all of that. They follow Revati. Rohini is basically Fagan and Bradley, and PVR we have Pushya Paksha and Mula Chandrahari. So there are more, but you can put them based on the anchor stars into these 5 major buckets. Okay, so I'm going to show one system as per the current definition. Okay, so I have taken Jagannatha Hora as the base software, and then I have taken the time. I have tried to recalculate. If you see here on True Chitra Paksha, so in this section, what you're going to see is, as defined by the author, do we have the Ayanamsa happening on the particular time, right? So that's what we see. So this is, if you see here, True Chitra Paksha, date and time is given. The longitude position is given here, sun's position is given here, and then how much of difference it has from reality. Actual astronomy difference is given here. If you take True Chitra Paksha, there is no difference. Okay, so these are the validation. You will see sun's magnitude, sun's location. You can see here, this is sun's degree. I would have given here 0 degree, you can see here. And then this is based on Spica. So I have taken Spica's position. I have given Spica's latitude, longitude. So these numbers are given for you. If you say here 20385, so that is what is given here. Based on this, you can calculate, and every year annual changes you can see here. Traditional Lahiri has, as I told you, it has a small error. If you come calculate, because it is forced to fixed number, it's not actual astronomy. They have introduced a minor error. So the minor error accounts for 0.27 years in the Jagannatha Hora software. It's not astronomy. Then we have Surya Siddhanta, so based one. So here it doesn't align well with current theory. So that's the observation we have. And then you have Revati based Ayanamsa. If you look at here, Revati, it was actually on 358. So this is again Surya Siddhanta based Revati. Sorry for rushing through, okay? Bear with me. So this is Pushya Paksha. Okay, so this is one of the popular ones. Let's talk a little bit in detail. So what PVR Narasimha Rao has taken is, he has given a definition of how this is calculated. Take the tropical longitude of Delta Canceri. So that is a star he has taken. If you take the value here, can you see here 106? So this is RA declination. This is not ecliptic longitude or latitude. So any Ayanamsa, you should define it based on ecliptic longitude. You don't define an Ayanamsa based on RAR declination. So he has taken a value, he is defined as 106, but this is not a correct implementation technically, okay? And then there is also another problem in the Pushya Paksha implementation in his software. You go back in time, you won't be able to find out the zero point in time. So the Ayanamsa jumps almost by 160 years in one second, right? So the base year cannot be calculated properly. So I would say the implementation and theoretical justification for this Ayanamsa is not alignment with astronomy. Okay, just for your information, I'm not going into detail. Rohini Paksha is correctly, based on definition as defined. So I have adjusted it to Uttarayana period. If you use that Uttarayana correction, it aligns very closely with the definition, both the sun's placement as well as nakshatra placement. Okay, and then if you look at Revati Paksham, so there is a difference of, this is what they've given. Revati Paksham, there are no clear definition of which year and which time. So whatever PVR Narasimha Rao has implemented, I have used that as a base here, and then I have calculated here. So if you look at here, this is how I derived at the number, the 389 year. So it is not based on Uttarayan. You see the value for sun. Sun is the sun degree is placed at 269. For a Uttarayana, it should be 0 degree. So this Ayanamsa is not positioned on Uttarayana date, so it is not astronomically correct. And then if you take K.S. Krishnamurti Ayanamsa, again, I adjusted it to equinox day. So it is also a little bit closer, but astronomically, there is a difference of 12.69 years. So he has used 297. So basically, he should have used 285. He forced fit a value and then he moved it to 297, which is astronomically not correct. Then Mula Paksha. So Mula Paksha is Chandrahari. Chandrahari has chosen a particular star within the Mula cluster. So he has chosen this star, So this is what Delta Scorpio. So the Scorpio. So this is what he has chosen. Technically, he should have chosen this particular star, the last star of Mula, but he has chosen this star, so which doesn't conform to his own definition of the star matrix. So this system also a little bit different. The implementation is different in Jagannath Hora, all of that. So if you look at all these systems, so wherever I say adjusted, I have moved it to equinox day, and then I calculated. If you look at all of that, Revati Ayanamsa doesn't have a Uttarayana equinox. Pushya doesn't happen on Uttarayana equinox. Sabari Panjangam, Chitra Paksha, CG Rajan doesn't happen on equinox. So other times adjusted. So if you look at pretty much all the Ayanamsa that are listed here with the base year, so they have a star, they have a date star degree, they have a per year movement, all are provided here. So based on the results, I would say, just based on just actual implementation, correctness of data, I would put true Chitra Paksha as the correct one, correctly calculated, astronomically correct. As Lahiri, I would put second. Fagan Bradley, Chandrahari are third. Pushya Paksha and others are below. Vakyam doesn't have a proper movement, so I will place it last. Okay, so that is astrology. So this is the actual database. Now let us look at how it has been implemented. So if you look at the anchor star, if you look at the base year time period, I have taken the base date time, base date degree. I have taken the base current time, current degree, and then calculated difference, and then calculated the yearly movement. What you have to understand here is every Ayanamsa that he uses, they don't have a fixed value for movement because stars move differently. They have a different movement value, which is like 50.0304. It changes. That's what you have to understand this. So this is the overall summary as implemented in Jagannath Hora. In Jagannath Hora, what you need to understand, Jagannath Hora or any other software, what you need to understand is an Ayanamsa may be correct, but whether they implemented it correctly, you have to validate that. Without that understanding, you should not use the Ayanamsa. So here in Ayanamsa, the author has introduced biases compared to actual data. So you can see the degree, how much of degree has been added or reduced here. You can see that Pushya Paksha, he has force-fitted the Pushya Paksha Ayanamsa here, which is not astronomically correct. Okay. Now, this is on just another summary. I have validated all the Ayanamsa choices listed in Jagannath Hora, and then I have adjusted it to the equinox, and then I have calculated. Okay, so there are none of this implemented correctly. Anything that is with X, you should not use this Ayanamsa from Jagannath Hora software. Okay, now I will quickly touch upon the methodology, and then I will talk about the results. Okay, so I'm not going to the detail. So what I have done here is I want to, instead of taking one star as the star, what I try to take is I take a star position as defined in astrology. For example, Chitra should be 173 astrologically. I have taken Chitra, when Chitra was in 173, I have taken that year as base. And then based on the data, I try to find a model of the entire astrology versus astronomical framework. And then I try to find out estimated model and then try to find out how much of which model has less error. So that's what I have tried to do. Here, if you take, Current approaches, they take one data point and then they say that is the correct approach, right? So what I am trying to do here is I am taking all the star positions and then I am trying to come up with a model which is in alignment with most of them, which has minimal error, right? That's what I try to do. So if you take two models, right, we have in statistical world, we use something called ordinary least square. So ordinary least square is basically a modeling tool. It tries to find out a model which is in close alignment with the reality. If you take this model, current models, they take two data points and then they come up with Ayanamsa, right? Either they take one star and then they say that is correct. For that matter, all the 27 data points in the star can be correct if you take just one data point, right? But whether that model fits the overall framework, that's what we are seeing. So between these two, where the error is minimum, error sum square is minimum, that is what is a better model. So this model takes into account all the data points. So that's why we find a better model, right? So that's what we have. So these are some technical details. So we have, we take the data position here, astronomical position, astrological position, and then we try to find the error. And then we find out with the model, which is best, which minimizes the error. That's what we use, okay? So we use something called, these are statistical terms, adjusted R square value, standard error, so, and then coefficient, all of that. So this is how you will run. If you collect the data and run your model, this is how you get the result. So you have to pick a model with higher R square, lower error. Okay. So what I have done here is, what is the correct position for the star? Should it be first beginning of the first pada, or it should be the third pada, or should be the end of the last one? So that's what I try to test here. So I have taken Chitra, kept Chitra to 173, Chitra in the current 204. I have run a model. I have run average position, beginning position, end position, all three possibilities. And then if you put a model, you find that, average position. Chitra is just one star, right? So average, minimum, max, all are same. If you keep Chitra at beginning, every star at the beginning, average position, so that model is better model. So in this model, if you see here, this model in over a period of time, 30 degree it moved. And then I have taken those positions, keeping Chitra at 173, and then I'm adjusting current data to 173. If you do that, so there are 4 stars which are not in alignment as per astrology. Okay, so these 4 stars are not in alignment, but this model has a better fit. So then let me move on to other models. These are like Moola based model, Pushya based model. Pushya has 3 stars, Moola has 8 stars. I have also done models. So if you look at them, Moola has 3 stars not in place. Pushya Paksha has 5 stars not defined in the Rasi. So like that, these are some of the findings. So based on the findings, what I found out is, keeping, as defined in astrology, you should put a star as per astrological position. And then when there are more than one star involved as a star cluster, it's always better to take the average position of the star. As per this, Chitra should always be considered as 173 and not 180. Okay, so that's the summary I want to give. Okay, so just need question time, please. I just want to
18 minutes more.
Okay, so we will quickly so sorry, yeah. So this is going to be a little bit technical, but I will cover it quickly. Okay, so sorry. So what I have done here is, just the way you saw for one nakshatra, I have taken all the 27 nakshatras, and then I try to find out between, if you use different Ayanamsa as defined by the author, so which model is, closely aligned with the Kalapurusha Tattva. That's what I try to do. So I have taken, as per astrologically defined position, the data, and then I try to fit a model, and then I come up with numbers, right? So these are like model fitness. Close to 1 is better, minimum error is better, few stars away from its alignment is better. So that's what I have done here. So you can later refer to this. So there are, if you take Chitra based model, right? So it has 4 stars not in alignment, but this has the better model compared to other models. If you look at any of these models, you will see this has more. This explains more variability in astrological framework compared to other models. And then if you take Pushya, 5 stars are not in alignment. The stars names are given here. And then if you take all of them, interestingly, if you take Ashwini, right, beginning of Ashwini as 0 point, it has a better model, astrologically better model, but there are 6 stars which will not be in the defined Rashis. Similarly, if you take Revati, it will have 7 stars not in alignment. So because of those reasons, so what I have done here is we are going to eliminate these two. These two are having more stars as not defined in astrology, right? So we are going to remove it. So these remaining 3, what I have done here is, this is past, present, and then I have also taken into account the future. So let's quickly talk about the future. Future is where we talked about the Chitra and Swati moving questions, right? So if you take the current time, so if you look at Swati here, Swati and Chitra, right? So they are very close to each other, right? So if you look at here, so they are very close to each other. In future, if you look at this chart, you see the transition between this, okay? So just to see the transition, the shapes are changing. I'm going to show you that. When the position changes, in this position, Swati comes ahead of Chitra. So let us take the time frame. You see, this is the time frame in future, 36453 CE. And that is when Chitra will go back and then Swati will come forward, right? So you can see the position, right? So that's the position here. So at that time, if you look at the degree-wise difference, Swati will come in front of Chitra astronomically. So that is when astrological current framework will break down. At the time, what happens? That's what I have tried to see. And then just observe this current view of the Rashi. I'm going to just change it. You see the Mula Nakshatra shape, it got changed. Right? Let me show you in a cutter view. If you see here, this is our current position, right? So current position is like this. Chitra is after Swati. Sorry, Chitra is ahead of Swati. When in future, what will happen is, you see, Swati and Chitra are coming together, right? In future, this is when that is going to happen. So at that time, you see how it changes. I'm just going to put them in alignment as per astrology. This is realigned to astrology, okay? See? So this is how the start positions are going to change in future, right? So all the stars move, all the Rashis, alignment will change. Just observe between the Shravana Nakshatra, the Chitra, and then you also see this Ardra Nakshatra, and then you see the Mula Nakshatra, these 4 parts, right? The whole structure of stars will change. So even at that time, so I tested the position there. Even at that time, so what I found was Chitra-based model, right? Chitra-based model still keeps it explains, it explains better than any other model that you will see, right? Pushya or Mula. So these are close candidates. Rohini, which is currently a better model, will not be a better model when in future. So based on these things, so I want to declare that the final verdict from my side is anything based on true Chitra Paksha model. So that is better model. Rohini based models come second, and Mula based model come third. So these are based on hardcore astronomical data. So my recommendation for you would be, if you are in doubt, keep true Chitra Paksha Ayanamsa if it is available in your software calculation. Okay. And also make sure it has been implemented correctly based on what I talked about. And then if you don't have a option available, you can use Lahiri, ensuring it is implemented correctly. Okay, in Jagannath Hora, it has been implemented correctly. And then if you are an app developer or mobile app or a software developer, instead of using a linear estimate for every year movement, use different time frame, the nakshatra position movement, and based on that, you should calculate the Ayanamsa. And Lahiri is a better second choice when you don't have anything else, right? And then don't use anything based on Vakya Panchang based calculations, right? So those are my recommendations for you. I will stop the presentation. We will open it up for Q&A. Good. Sorry, I ran a little bit over time. I could not do that.
No,
Yeah.
I think we are still perfect. Thank you very much. I think it was astronomically enlightening, to say the least. So don't thank me. Thank Ramesh for his brilliant research and exceptional presentation overall.
So it was a 10 hours plus presentation. I try to rush it through
Yeah.
in 1 hour. Sorry for that. A lot of details. And again, it's technical, so it may not be appropriate for every audience, astrological audience.
Yeah. Yeah, I think some people may have found it very, very interesting. A lot of people had food for thought, I'm sure. And I mean, everyone would have found it interesting. For some people, it may have been complicated, and it puts us into a different way of thought process. But I'm sure everyone needs to engage with these subjects, especially astronomy and mathematics to some extent. I don't know about statistical models. I'm very layman to those things, but I think astronomy and mathematics is really important. So the way you put everything together in terms of understanding the positioning of a particular star, and then how we calculate the ecliptic longitudinal positions, and then fitting the zodiac, whether or not, basically, if it is accurate or closely accurate, was really interesting. And also the stars, that I think your conclusion was that Chitra is a better candidate than other nakshatras. There are other stars as well. The Mula is basically taken because of the fact that they want to align the zodiac to the galactic center, which is an entirely different theory. David Cochrane gave something like that. That is a galactic center, Ayanamsa. So I think there is a lot for us to follow. Hopefully, your work is a good beginning for everyone to get into this rabbit hole. But thanks, it was really good.
Yeah, certainly. Yeah. And again, as I told you earlier, so I don't want you to, this is not like judgment. So I want you to explore. Anybody who is an astrology student, you should have a very strong hold in astronomy. Astrologers were the first astronomers. So only because of astrologers, astronomy has developed, or into the current level. So we should not forget our roots. We should always go back and, when you're in doubt, go back, stick to your old school principles, learn astronomy, and then you become a more confident astrologer, I would say.
Yeah, that's great. I don't have any questions. I will most certainly go back and watch. But I think I've been in this same rabbit hole many times. So, any questions, Ramesh?
Yeah, you can.
Hi, Ramesh sir. This is Vignesh.
Yeah, please go ahead and ask your question, please.
Yeah, this is more of a not a query, but I was very what do you say, excited I got answers for a few of my questions. So I had very primitive questions, and this session cleared a lot of most of those queries. Maybe I'll get in touch with Ramesh sir in person, and I'll get to know more about this. Thank you. Thanks for this session, sir.
Sure, Vignesh. So there, anything after we are done with live, so there are a few questions in chat. Maybe I will try to answer it if time permits.
Not sure
I
if
think
there's
somebody
a
made an
question in chat,
observation
but
about
there was a
PVR
comment.
Narasimharao. Yeah. So somebody, I think you also, yeah, I think it's yours. Now Chitra not in 180-degree, right?
Yeah, Chitra is not in 180. That is the biggest adjustment that we need to do when we use Chitra.
Okay, so let me explain that. So what they have done with the word Chitra being 180 is, so Chitra can be in 180 in particular year, right? All the
Yeah.
stars move. So whether you keep, what they are saying is, they don't say, I think Rashri Panjangam and the proponents did not say that Chitra should be kept at 180. That's, I think that's a wrongly perceived notion about Rashtriya Panchangam or Lahiri. So what they were saying is, on this particular day, this star was at 180. Chitra was at 180. They did not say that that is the correct position for Chitra. So I also compared model between Chitra keeping 173 versus 180. The 173 happens prior to 285, which is which I showed you, right?
Yeah.
Let me, yeah, so that happened somewhere 300 years earlier to 285. So at the time it was 173. Ideally, if you compare model of keeping Chitra 173, 180, the model kept at 173 is much superior than model kept at 180. So that's where I try to answer. Chitra should not be considered as the middle or third pada, beginning of third pada. Every star that is defined in astrology should be considered as beginning. And when more stars are involved, take their average and keep that as beginning for the particular star.
Right.
So
But
technically, yeah.
No, go ahead.
So technically, Lahiri or whatever they implemented it correctly. Probably there is a misconception that it is being forced into 180. That's not correct.
Right. I have one more follow-up question, which is just occurring to me. Should we be careful about the anchoring of the zodiac to the eclipse when we are looking at an anchor star? Because Chitra is not necessarily exactly anchored to the ecliptic. So do you consider that point, or?
Okay. So for that matter, if you look at the star position, right? Most of the stars are not on ecliptic, on the close to zero.
Sure.
So only few candidates are close to zero because that is moving, right?
Yeah.
For that matter, if you look at currently, Swati is way above north. So it will come down close to Chitra. It will hit at some point of time. It will also go south. So
Right.
we should not be. That is not a very solid argument. Anything which is defined with we are not taking anywhere the latitude of it, right? We are always talking. Ayanamsa is always about longitude. We don't talk about latitude anywhere.
Sure.
Even stars, we don't talk about latitude. We always talk about longitude. For that matter, Mula is well below, the ecliptic. So that's not a very strong argument, I would say.
Okay. Anyone else?
There is one new message. Anyone want to unmute and ask questions?
I mean, I have a basic question. When we have so differences, I am Nansha and all those, how can we make sure that predictions are right? Right? Yeah, end of the day, who cares what system is, right? I mean, predictions are going to be wrong, then people are not going to trust it, right? I mean, typically I see two things. I mean, so I write two things. If a doctor do a wrong diagnosis, people don't call medical profession as a wrong profession. They say doctor is bad. Whereas in astrology, if astrologer predict wrong, they condemn entire astrology profession itself, not the astrologer. Or I read somewhere we have more failure on statistical model than the astrological model. I don't know what is right or wrong because statistical model need to have a lot of parameter, right? End of the day, with the given uncertainty, right? People want to be in control. They want to know what exactly is going to happen. And if we have so much differences and whatever, right? So how we are going to pinpoint who is right, giving right predictions, right?
That's a very interesting question. I think I opened the session with that argument, and then I explained about where the diagnosis itself is going wrong. I mean, the measurement itself is going wrong if you use a different set of Ayanamsa. We saw that, right? The whole purpose of this session is probably bring people to an alignment based on scientific data, try to use probably one Ayanamsa, better Ayanamsa, or at least the next best candidate to be used instead of randomly using every Ayanamsa. Because if you use different Ayanamsa, you're going to get different results. The second part of it is everybody thinks that astrological prediction should be 100% accurate. So I would say even Parashara did not talk about that in Brihad Parasara Varasastra. He says, this is the best we could figure out from it. Things could go wrong. When the proponent, the authors themselves are not claiming 100% accuracy, many of the practitioners are focused on making 100% accuracy in predictions, which is not needed. And then basically you are putting yourself for a tall ask. I would say on the larger scale, on a higher number of samples, if you are able to make a reasonable prediction, anything above 50, that's what we are targeting. If you are able to get closer to 100, that is great, you are God. Even Parashara says we are able to get only probably 70 to 80. So we are not certainly doing a 50-50 job, rather we are trying to get closer to the maximum possible. I would say if you keep on using different Ayanamsa, you're not going to get any results. Stick with one which is scientifically kind of more sound, and then try to use it consistently and try to improve the prediction part of the astrology. That's what I would recommend.
So one more question related to this. So what happens to the countryside people in Tamil Nadu or somewhere in North or somewhere in West Bengal? Because in West Bengal, a lot of good astrologers are there, right? I don't know what Ayanamsa they are using, but they may not be using software also, right? But there are a lot of predictions goes true, right? So I mean, what is the basis for that actually? More intuition than all those things, or what is the deal on that?
So the whole discussion is about Siddhanta part. The second part is all about prediction part, modeling part, is the Hora Skanda, right? So in Hora, it requires quite a bit of even if you use. I don't think anybody is sitting and looking at divisional level charts anywhere, except somebody using a modern software, right? If you go back to countryside, so they are kind of they're used to making predictions. They don't need so much of details. Only when you get into something like you talk about a past life karma, go to D60 chart. I don't think anybody in the countryside is doing that level of detail. I would say you develop some expertise over a period of time, but everybody starting on a technically correct one is what I'm recommending here. Subject-wise, subjective, expertise play a role, but that cannot supersede a technically correct Ayanamsa.
Thank you.
Thank you so much. Thanks for the question. Thank you, Dr. Ramesh. I think it was a great presentation. I think you have your work now. Thank you so much for taking the time early in the morning and doing this for us. And thanks everyone for joining. And I hope you enjoyed this session. We will come back for Muthu's workshop on Muhurtas or electional astrology in India in about 1 hour.
Thank you, Ashwin.
Thanks.
Thank you, Muthu. Thank you, everyone. You have a good rest of the day.
Thank you.
Bye.
Thank you so much.
Thank you.
Thank you for
Thank
joining.
you very
Yeah,
much.
bye.
Thank you very much, sir.